Okay, here we go. More chapter 6 review. We'll call this part 2 since I'm breaking this into 2 chunks. Okay. So, number 8. I'm going to just keep going off of the previous numbering. Given a sub 1 is equal to 3, a sub 2 is equal to 15, what if I was asked to find a sub 10? So, this here is an opportunity to show that you understand this particular relationship. I can find any position, and actually, you know what? I'm going to tell you one other fact here. I'm going to tell you that this is a geometric sequence. So knowing that it's geometric, then, if I just know what's in the first position and I continuously multiply by my common ratio, n minus 1 times, I can get to any position. So if I want to get to the 10th position, I know there's a 3 in the first position times my common ratio. So if I get from 3 to 15, I think most people would probably realize I'm multiplying by 5. Now if I didn't realize that, I could just take that 15 and divide it by 3. So I'm going to go times 5, and if I'm going to the 10th position, it's going to happen 9 times. So 3 times 5 to the 9th is actually a pretty big number. 5,859,375. Okay, let's practice some summing. Number 9. Find the sum of the first 100 odd integers using the reference sheet equation, we'll say. So if you recall, if you look at your reference sheet, which you should have handy hopefully, the sum of an arithmetic series is equal to n times a sub 1 plus a sub n all divided by 2. So I'm going to bring that back on over here. So s sub n is equal to n times a sub 1 plus a sub n all divided by 2. Let me just see if I've written that the way it is on your sheet. Yep. Okay, so if I'm trying to figure out the sum of the first 100 odd integers, I'm going to put 100 here. And so my n up here is going to be 100. And so now I might have to take a moment and say, well, let's think about odd integers. 1, 3, 5, dot, dot, dot. So I know the first one is a 1. I don't right now know what the 100th one is. So I'm going to come marching over here and I'm going to say, well, I can figure out what the 100th one is, because if I just say the first one's a 1, plus it takes me 99 steps to get to the 100th position, and the common difference I'm continuously adding 2. So 99 times 2 plus 1 gets me to 199. So I'm going to come back over here and drop that 199 in here, and now it's just a little arithmetic. So if you multiply those out, you get 10,000. Okay, another one. Find the sum of the first 25 terms of 2, 6, 18, dot, dot, dot. So, first thing you need to do is decide what kind of a sequence you have on your hands, and hopefully you will quickly realize that this is not arithmetic. It is geometric, where we have an r of equal to 3. We're continuously multiplying by 3. So if I go over to my old sheet again, I can look up here and see that the sum of a finite geometric series is a sub 1 times 1 minus r to the n all over 1 minus r. So I'm going to transfer that back over here. So s sub n is equal to a sub 1 times 1 minus r to the n all over r, and you'll see in a lot of ways this is pretty easy because I don't even have to figure out like the 25th term or whatever. So my first term is a 2 times 1 minus, and I'm going to write over here what is it I'm trying to do, sum 25 terms. So 1 minus my common ratio, which I've already figured out, is 3 to the 25th, and then this is all going to just be divided by that. Whoops, I wrote this equation wrong. Oops, 1 minus r divided by 1 minus 3. And if you were to do this in your calculator, you will get a crazy big number, just for fun, which is 8.472886094E11. And just to remind you what that means, it does not mean raised to the 11th power. This E means times 10 to the 11th. So if I wanted to actually write this out, I need to move this decimal place 11 to the right. So 2, 3, 4, 5, 6, 7, 8. Wait a minute. 1, 2, 3, 4, 5, 6, 7, 8, 9. Did I leave something out? 1, 2. Yes, I did. Okay, this is not what this video is about, but I'll try to do it right. Anyway, so 8, 4, 7, 2, 8, 8, 6, 0, 9, 4, and I do believe we need 2 more zeros, so you can see that that is a big number. 847 billion and a little bit more. Okay, continuing on. Number 11. Say you buy a car. For $20,000. You buy a car for $20,000. It depreciates 17% per year. How much is it worth after 5 years? So, first year, it is worth $20,000. And if I want to know how much it's worth after 5 years, this is after 1 year, 2 years, 3 years, 4 years, 5 years. I just want to make a point here. And the point is that this is the first, second, third, fourth, fifth, sixth position. So you got to be a little bit careful about what position you're in. So this is what we call a geometric sequence. And as I said in class, if we were in middle school and we wanted to know how much it was worth after a year, we'd have to say, well, what's 17% of 20,000? And then we would subtract it. And so it would be a two-step process. But since we're here in the big algebra trig, instead I can say, well, if it loses 17% of its value, how much does it keep? So 100 minus 17, I do believe, is 83%. So instead what I can do is just multiply by 83% in a decimal form. And every year from after year 1 I can continue to multiply by 0.83 and I'll know how much this vehicle is worth. So what I'm looking to figure out is what's in the 6th position. And the first position is my $20,000 shiny new car. And I am going to continuously multiply by 0.83. And I'm going to do that 5 times. So if you multiply that out, and let's say the question just said round it to the nearest whole number, you should get something like this, $7,878. Okay, another problem along the same line. Say instead you put $100 in the bank at 5% interest. How much will you have after 5 years? So, same thought process. If we were in middle school thinking, we'd have to say, well, what's 5% of 100? We might use a proportion or 0.05 times 100, and we'd figure out how much money we made the first year, and then we'd add it to that 100, and then we would have to figure that out and multiply it continuously. But if you notice, 5% of 100 is 105. And so if we started with 100 the previous year, basically if we just multiply by 1.05, we figure out how much we have after 1 year in the bank. And then if we multiply that number by 1.05, we figure out how much we have after 2 years in the bank. So same thought process. I'm really looking to get into the 6th position. The thing that's in the first position is 100. And I'm going to keep multiplying by 1.05, and I'm going to do it 5 times because 5 years is going to go by. So if you say the question were to say, give me the number to the nearest whole dollar, you would get $265. Okay, I'm going to check my time again here. Time flies. See if I can get a couple more problems in. Maybe I'll do 2 more problems. Let's see here. I just did problem 12. We'll do 13. Just another thing about arithmetic means. Say I was asked to find 3 arithmetic means between 12 and 56. Put a 12 down, 1, 2, 3, I can put a 56 down. Just want to remind you of another relationship that goes on. I could do the same thing I did in a previous example problem, but if you notice, this number here is exactly in between these 2 numbers, and so it is a fact in this sequence. If I add 12 plus 56 and divide that by 2, I will get the number that's sitting in this position. So 12 plus 56 divided by 2 would be 56, 66, 67, 68 divided by 2 is 34. And then I could actually do that same exact process again to get myself into this position. So, because I have a 12 here and a 34 here now, I can say 12 plus 34 divided by 2. And so 12 plus 34, 34, 44, 45, 46, 46 divided by 2 is 23. So at this point I could either, now I can see what my common difference is and just add that over here, or I could do the same thing with these numbers and you'd end up with a 45 here. Just wanted to remind you of that relationship. Okay, one last problem. I do believe, here we go. Problem 14. Say we were asked to find the following. The summation from n equals 1 to infinity of 1/5 to the n. So, this would be a problem that your brain needs to say, alert, alert, something's going on here, and it has to do with this situation over here, where my r is a fraction and I'm summing to infinity, as in this is what I'm going to use. So I'm going to come back over to my other place here, and I'm going to realize in order to do this I need to say S sub n is equal to a sub 1 over 1 minus r. Now you might say, well, what's the r? Let me just come back to this for 1 second. If you were to fire this machine up, you would notice that when you put the 1 in, 1/5 to the first power is 1/5. Then you go up to 2, so you get 1/5 to the second power, etc. Your exponent is just going to keep changing. So hopefully then you can realize that in this particular case, my first term then is going to be 1/5 all over 1 minus. Well, what's actually happening here? Well, I'm starting with a fifth, and then this next term is a fifth times a fifth. And this term, if I was going to write it, is a fifth times yet another fifth. So my common ratio is also a fifth in this particular case. So if I take 1/5 over 1 minus 1/5, and just for fun, I'm going to do this out. So 1/5 over 1 minus a fifth would be 4/5. And if I keep the top, change from multiplication to division, and flip the bottom, in the end, that would add up to 1/4. So I think that's it for now. I'm going to end this and can come to ask me questions if you have any.